Hello everyone, my name is Raghav, and today we are going to discuss the problems of the contest Starters 89. It happened yesterday, and I was able to solve the first seven problems. I will discuss them only. I won't discuss the eighth problem. I was not able to solve it because I might make a video on this in a few days. So for now on, let's discuss the first seven problems. Out of these seven problems, the first three problems are gonna be really basic because these problems are being included in the contest so that the beginners can also solve a few problems and might not feel like they were not able to solve any. So for the first problem, it says that an important resolution is being discussed in the Parliament of Sheffield, and there are N people present in the Parliament, out of which X members voted in the favor of the resolution, and the remaining voted against it. So, according to the Constitution of Sheffield, a resolution is passed if and only if half of or more than half of the members present in the parliament vote in favor of the resolution. So basically what it means is that the number of people who have voted in favor of the resolution should be either greater than or equal to the number of people who have voted against it. Right? Half or more than half does mean the same thing. So what I can do is let's move this and write it again. So, by the way, the inputs are in the format that the first one is the number of people and the second one is the number of people who have voted towards for it in the favor. So here we will see that in text and in an index. Let's take the inputs. Now the number of people who have voted against, right, is gonna be equal to n minus x. This spelling is wrong. The number of people who have voted against it is equal to n minus x. So if x is greater than or equal to against, then the answer is yes, right? That's what we have been given in the problem. In case if you are feeling any problem with this thing and want to really solve it in a way, the problem was being told that half or more than half of the uh, members in the parliament. So we can just simply compare if x is greater than or equal to n plus 1 by 2, then print yes, otherwise no. You can write it in that manner as well. But I'm writing in the manner which would be helpful for you for solving the first three problems really easily. And let's try to submit it. While it is being submitted, we will move on to the second problem. It has an error. Oh, sorry, I forgot to add these brackets. That was a typing mistake made by me because I was being focused on explaining what I'm doing. Please don't judge me on the basis of this. There are four companies in the market of Sheffield, A, B, C, D, and PQRS are their respective profits. And uh, there is said to be a monopoly in the market if the profit made by one company is strictly greater than the sum of the profits made by all other companies. Determine if there is a monopoly in the market or not. So one thing is really obvious that if a company is having a monopoly and is having um, the profit of that company solely is greater than the sum of the profits of all other companies, then that company must be having the highest profit among them. So why don't we just find the maximum profit? That's what we did. We just said that maximum of ABCD, and a lot of you might not know about this, but in case if you want to use the max function for multiple variables, then you can include those variables in curly braces and you would be able to find the maximum of them. And we just calculated the sum of these variables, and then we said that if mx, that is the profit of the company with the maximum profit, is greater than the sum minus mx. We are excluding mx from the total sum so that we can find the sum of the other three companies. If this is greater than that, in the problem we have been given strictly greater than. That's why we have been using the greater than operator. Otherwise, we might have been using greater than equal to operator if it was given that way. And in case if it satisfies the condition, then we will print yes. Otherwise, we will print no. And that's how the problem is going to be solved. I did submit it and it got passed. That's why I'm not going to submit it again. Now let's come to the third problem. So the third problem is a little tricky, maybe a little tricky for beginners who are not like familiar with strings. Um, this can also be solved with character array as well, but here we are going to solve it with strings only. So let's read the problem first. In this problem, it has been said that chef is confused by all the different formats dates can be written in, and here is a simple problem chef wants you to solve. You are being given a date string. The date follows the like there is some name calendar, the one used in most blah blah blah. Basically, the most important thing is that we would be given a date, we would be given a string which is representing a date, and we have to tell whether it belongs to this format, which is the date, month, and year, like belonging to this format and not this, or belonging to this format and not this, or belonging to both of the formats. So the obvious things, like just talking about the obvious things, is that if the first, like let's call it as the first number, second number, third number. So if the first number is greater than 12, it means that it must be representing the date, right? In that case, I can just simply say that this is this format, because if this is greater than 12, then this cannot be this format, and I just simply get my answer. Otherwise, I will check if the second one is greater than 12 or not. In case if the second one is greater than 12, then I can simply say that this is the format. But if neither this one is greater than 12 nor this, or basically both of them are less than or equal to 12, in that case, this can be any format. Like when I see this, I can tell that this is representing 21 May. When I see this, I can say that this is representing 15th of August. No, sorry, not August, but October. But when I see this, I cannot say if it is representing 5th November or 11th May. It can be any of them. So I have to print both for that. And here's my code. I said that first is equal to date.substr. This substr function is used to get a substring. The first parameter is the index from which I want the substring to start, and the second one is the length of the substring. So I want to obtain these two. It is starting from the 0th index and of length 2. For the second one, it is starting from the third index and is of length 2. And this stoi function will take a string as a parameter and convert it into an integer. And that's what this would also do. And after that, I can just simply check if first is greater than 12, second is greater than 12, and if both of them fails, in that case, I will print here, both. Okay, so simple till now, right? I think that this was really simple till now, and I hope you also felt the same way. Now we are going to dive down into something more interesting. You might feel like you might start enjoying CP from here. The first three problems, you cannot call them CP problems anyways. These were just added in the contest so that beginners can solve, but real contest starts from here. So this problem says that chef has a number x whose value is chef has a number x whose value is initially 0. In one move, he can do any of the following. I'm coming in just a minute. Yeah, so I'm back, and now let's discuss this problem. So in this problem, we have been given that chef has an integer n, and it is initially 0. And in one operation, chef can either increment that value by 2 or decrement it by 1, and he can perform that operation at most y times. And now he wants to know how many distinct values can x have after performing at most y moves. So let's see the example test cases first. In case if the value of the number of moves you can perform is 0. So basically you cannot perform any move. The default value is 0 and that's the only value you can have. So the answer is going to be 1. This is the only distinct value. In case if you have one operation, then what you can do is either, so here what you can do is like either apply the plus operation or minus operation and you will have these three values. If the input is true, then you will have like a few choices like not applying any operation, applying only like decrementing once, decrementing twice, decrementing and incrementing, incrementing only, and incrementing twice. And let's come to the logic. How can you think about the answer? So initially you have 0 and the number of operations can be let's say 2 to 4 right now. It can be any number. Uh, for now, just for the like matter of simplicity, I'm taking n is equal to 4 and we will generalize it later on. Whenever you see a problem on any platform, you just like for the easy problems like these, you just try to find out patterns and you do it by taking random examples. So initially you have 0. What you can do, just think about applying the incrementing operation only. So you can get 0, 2, 4, 6, and 8. If you just apply only the decrement operation, then you will have 0, minus 1, minus 2, minus 3, and minus 4. Now talking about the combinations. So on the left side, you cannot get anything else. Even if you just apply the decrement operation twice and then apply an increment operation, it would come back to 0. So there is no sense. It literally makes no sense of applying it that way. But applying the decrement operation after reaching 2 makes sense because in that way you can get 1. If you apply it, if you apply the decrement operation after reaching 4, then you can get 3. And in the same manner, you can get 5. But you cannot get 7 because reaching till 8 will cost you 4 operations. Basically, you have exhausted yourself and now you cannot apply any more operations, so you won't be able to create 7. So between the numbers from minus 4 till 8, which is basically 2n and minus n, if like for any value of n, this would be 2 now. From 2n till minus n, you have been missing only one value. So the answer is gonna be something like from 2n like plus 2n till minus 2n, which is gonna be uh, 2n minus n plus 1, and you have been missing one value, so it's gonna be minus 1 and just cutting out it, so you will get 3n. The reason I did this to find the numbers between this range, it's basically a formula which everyone would have learned in the childhood. That let's take an example that you want to calculate the number of students from roll number 1 till 7. So you don't call it 7, you call it 6 plus 1. Like you don't call it 6 because of the difference. You add 1 to take consider all of them. In the same manner, we just added 1 there. And like I think that this is something really basic and you would be able to understand on your own. And like this part you should be able to understand on your own. And we have got the answer to be 3n, right? Let's see, is it? like let's try to verify the answer we have got with the sample test cases. So here you can see, by the way, this is true for n greater than 0. In case if n is only 0, then this minus n is going to be equal to 0. This plus 2n is going to be also equal to 0. And we have 0 there. So from 0 till 0, this basically doesn't make any sense now. You can, why complicate something when you can just simply give the answer? And for everything else, this makes a lot of sense. Um, it doesn't mean that for n is equal to 0, it will fail. You will get it, but you have to make some modifications. And just to keep it simple, I'm going to use, like when I did submit the problem, I did something like this: if n is equal to 0 and if n is not equal to 0. You can just divide this into two cases. And I did submit this, it got accepted, so I'm not going to submit it again. And let's come to the fifth problem. The fifth problem is a little interesting. Till now, the problems were really simple, but now onwards, you will see problems which are not direct, they are a little twisted. For example, first of all, let's clear it. For example, in the problem, we have been said that consider an array A of length n such that ai is equal to 2 raised to the power in minus 1 for all 1 till n. So there's an array A. The array A is going to be A1, A2, A3, and so on till an. This a1 is equal to 2 raised to the power 1 minus 1. This a2 is equal to 2 raised to the power 2 minus 1. This a3 is equal to 2 raised to the power 3 minus 1. And this an is equal to 2 raised to the power n minus 1. Let's keep it small n. So basically the array A, oh yeah, by the way, this 2 raised to the power 0 is equal to 1, 2 raised to the power 2 is 1 is equal to 2, 2 raised to the power 2 is equal to 4, and if you write A4, A5, A6, A7, you would just see that these are getting doubled and doubled and doubled. So this array is basically nothing but 1, 2, 4, 8, 16, 32, and so on till 2 raised to the power n minus 1. Okay, and I just wanted to show you how to derive this. That's why I wrote this, but I don't really need this. That's why I'm going to erase it. And let's recenter it. Yeah. In the next line, we have been told that we have been given an integer array. This is something which we have been given an input. Here in inputs, we have been given the integer array b. In the integer array b, all of the elements are either going to be plus 1 or minus 1 for all of the elements. And we have been given another array c, like, sorry, we are not given. We have to create the array c of length n such that ci is equal to bi into ai. We need an array b, right? Let's take it from the sample test cases. In the sample test cases, we have been given 1 minus 1, 1, 1, 1 minus 1, 1, 1, and both of the arrays should be of equal size. So Ci is equal to Ai into Bi. That is going to be 1 minus 2, 4 into 1, 4, 8 into 1, 8. And now we have to tell the number of tests, like in the problem. If you read further, you would see that in the problem we have been said that let the number of subarrays of C having sum strictly greater than 0 be P, and for the number of subarrays of C having sum strictly less than 0 be Q. And we have to determine the value of P minus Q, absolute of P minus Q, absolute difference between P and Q. First of all, let's try to find the number, like P and Q. Let's try to find P and Q. So initially P and Q are basically 0. We will just keep looking for the subarrays and adding them. We will keep adding them. One of the subarrays is 1. Let me use a different pen. One of the subarrays is 1. This is positive, so I incremented it. Let's increment it properly. Another subarray is 1 comma minus 2. This is negative, so we will increment q. I will increment q by 1. If you carefully notice, even if I remove this, it will be minus 2. So I can increment it once again. For considering 4, here 4, if you notice, 1 minus 2 4 or minus 2 4 or 4, all of these are going to be having positive sum because 4 is greater than, like, the absolute of 4 is greater than the sum of absolute values of these. Basically what I want to say is this. What I want to say is that 1 plus 2 plus 4 plus 8, if you just keep doing this, you would always see that these are always going to be smaller than the next value. So, if this is having a negative sign, in this problem we don't have a 16, but I'm talking general that if this has a negative sign, in case if B 1, 2, 3, 4, 5. Like 0, 1, 2, 3, 4. So if B4 was minus 1 and then A4 into B4 would have been negative. So even if all of these are positive, it would still be negative. So what I can say is that I have 1, 2, 3, 4, 5 points from where I can start the subarray. And if I finish on this subarray, it would always have a negative sum. I think that a lot of people might be having trouble with this approach. The way I was trying to tell about the solution is something where in the method I think about the problems, but for now let's keep it simple. I will make all the summaries and I hope that you would be able to see the pattern yourself and then I will explain it. So let's create all the summaries. One, I have counted it. Now 1 minus 2 and minus 2. Then I did count 1 minus 2, 4, minus 2, 4, and 4. This was another subarray. And the other part of the subarray which I have, like, I didn't count this time. So these are 3. Let's call it 4. I have counted these 3 subarrays as well, which have positive sum. Now the subarrays ending at 8. 1 minus 2, 4, 8, minus 2, 4, 8, 4, 8, and 8. All the subarrays ending at 8 will have positive sum because 8 is positive, and even if all of these have the opposite sign of this value, they would still not be able to change the sign of the sum of all the values. So by just looking at the sign of the last value, the end of the subarrays, for the subarrays which have been ending at 8, by just looking at 8 I can tell that all of them will have positive sum. Here I have 8. So I hope that you were able to notice that I don't really care what were the signs for the values previous to this. By just looking at this value, I can tell that all the subarrays which have been ending here, which have been ending at this point, will have positive sum. So if this is the third value in the array, then I can simply add 3 to my to the value of p, and let's say if it was negative, then I know that all the subarrays which have been ending at this value, this element will have negative sum. So I could have added actually 3 to the q, the variable q. Let's take another example to make things more clear. The example can be this one. A is equal to 1 to 4. B is equal to minus 1, minus 1, minus 1. C is gonna be equal to minus 1, minus 2, minus 4. Now P is equal to 0, Q is equal to 0. All the subarrays ending at -1 will have negative sum. There is only one subarray ending at this one, so I will increment it. Now all of the subarrays which have been ending at this element will have negative sum. There are only two of them, so I will increment it. Now again, there are three subarrays which are ending at 4 or -4. All of them will have negative sum, so I can simply add them as well. And P is equal to 0, Q is equal to 6. Absolute difference of P and Q is equal to 6. That's my answer. For the last case, I had 8, the value of P to be 8 and Q to be 2, so the absolute difference was 6, which we can see here as well. So the thing which I wanted you to notice was that I don't really care about this subarray. Sorry, I don't really want to care. I don't really care about this array. I only care about this array. If I see a negative, then let's say if I'm indexing the arrays as 0, 1, 2, and I find a -1 here. So what I'm going to do is go to the variable q and add I plus 1 there. Why I plus 1? Because this is zero based indexing. For the element at index 0, there would be one subarray ending at that index. For the element at index 2, there would be three subarrays ending at that character, right? So that's why I'm adding I plus 1 there. And in my implementation also, you can see that I did the problem in the same manner. I just traverse over the array, this array, saved it, and then I declared two variables p and q, and then I traverse over this array and said that if num_size is equal to 0, if num_size is equal to 1, then I will add I plus 1 to p, otherwise I will add I plus 1 to q, and then I will print absolute of p minus q. So this problem is as simple as this, and I hope that you were able to understand till now. And I need like a break for a few minutes to relax my like relax my इंग्लिश कमजोर है भाई की मतलब गला खराब हो रहा है ये कहना चाह रहा हूँ बस तो कुछ मिनट हम लोग को ब्रेक चाहिए उसके बाद मैं आके अगला प्रॉब्लम डिस्कस करूंगा so I'm back and now we are going to discuss the sixth problem and now on the sixth problem we have been told that chef has a permutation a of length n and chef can perform the following operation on a. The operation is that select any two indices L and R and remove this and like it would be a subarray between the names from L to R. Just remove it from the array and concatenate the remaining parts. And here we have been said that R minus L plus 1 should be less than L. R minus L plus 1 is nothing but the length of the subarray which we are going to like remove from the array. So it should be less than L. It means that it cannot be the complete array. It should be a part of that array only. Because like when you would read the problem, you would understand that if it could be equal to n, then there would have been no sense of the problem. Okay. If you'll go ahead and see it has been said that the score of the operation is the length of the subarray removed, that is R is equal like R minus L plus 1. And we have been given an example. So let me show you the example that the array A is 314652 and chef selects the array 465 and after removing this from the array will become 312 and this is a permutation. You would like first of all let's complete the problem and then we will come back to the example. You would understand it in a better way then. So chef wants to perform the operation exactly once. The operation which we discussed earlier should be performed exactly once, which means that you would have to find only one subarray and remove it. So after the operation, when the two parts of the array have been concatenated, one on the prefix and one on the suffix, A should still remain a permutation. A would be having less number of correct elements, as in this case when you remove 4, 6 and 5, A is equal to 3, 1, 2. So this is also a permutation of 3. This is still a permutation, and basically we want to maximize the score that chef can achieve in doing so, and this condition should hold. This condition should hold. The way I am speaking so slowly is because this part is a little complicated. A lot of you might be facing difficulty in understanding this, so that's why I've been speaking so slowly right now. Uh, I don't want to go fast, which might confuse a lot of you. So let's see this example once again now. In the example 3, 1, 4, 6, 5, 2, chef can remove from L is equal to 3 to R is equal to 5, that is 4, 6, 5, and the score of the operation is going to be equal to 3 because the length of operation, the length of the subarray which we are removing is 3, and after removing it, when we concatenate the prefix and the suffix, it would be 3, 1, 2, which is a permutation. Now, what I want you to notice here is that you cannot remove 4, 6. You cannot remove something like 4, 4, 6, or just removing 5 from the array. Because if you do so, then you know that the remaining part can never be a permutation because everything was coming exactly once. Just imagine if you remove only 4, then the remaining part would not be able to become a permutation. So if you have been removing 4, then you must remove all of the elements from the array which are greater than 4. So let's say if I wanted to remove 2 from the array, then I have to remove 5, I have to remove 6, I have to remove 4, I have to remove 3. But in the process, when I want to remove 3 as well, 1 comes in the way, so I have to remove it as well. Otherwise, I won't be able to remove 3 because 3 and 2 should be a part of the same subarray. So 1 would also be coming in that subarray, which would like it would contradict the like it won't satisfy this condition that the subarray should not be equal, the length of that subarray should not be equal to n, it should be less than n. Um, like the important observation was this one, that if you are going to remove 4 from the array, then all the numbers which are larger than 4 should also be removed from it. Now let's see the example test cases. Here in the first example test case, we have 2, 1, 3. As it was being mentioned that the array A which we will be having is gonna be a permutation of n. So this is a permutation of n. And now we have to remove a subarray from the array. The remaining part should remain as a permutation, and we want to maximize the score. In this case, you can see that if you try to remove anything other than 3, then it won't result good. That's why the answer is 1. In the second test case, you can see that like you can remove this whole subarray and you will still have a permutation, while it's a permutation in itself, and in this manner you will be able to get the maximum score. In this third example, this is the one which we discussed here, so it's the same thing, and it has been explained here as well. um, this problem is not that simple like the previous problems. If you look at the previous problems, they were really simple. And even if you look at the submissions, like successful submissions, so the fifth problem was having over 1400 submissions, 1481 to be precise. Whereas the sixth problem is not even having 100 submissions. So in case if you think that like you have been facing some difficulty in understanding the sixth problem, uh, if you are a beginner, if you are rated lower than 3 stars, like just 1 star or 2 star, then you can stop the video from here. Like this might be, this might overwhelm you, uh, which is not something which I want. So you can take a break. You can just enjoy, like absolving till 5 is good enough for a 2 star coder. But if you are at 3 star or higher, then I would recommend you to like solve this problem and this one as well. The seventh problem is even simpler than the sixth problem, I think, though the solutions are a little lower. So now let's see the problem. The reason I was saying that this problem is hard is not to make you feel just leave it, but just to give you confidence that it's not your mistake in case if you are not able to solve it, or in case if you are not able to understand it, then that's not your mistake. The problem is a little higher rated. The ratings are not being given till now, but I think it should be around 1900 or 1800. And the seventh one, maybe around 200,000. It should be around 2000. And the seventh one should be around 2200. So you can leave those problems if you are below 3 stars. Now 314652. 314652. The thing which I want to say is that you want to have a permutation, right? What if we discussed one thing that if you try to remove 4, if you try to include 4 in the subarray which you are going to remove in the future, then you must include 5 and 6 as well, right? And these should come in a subarray. So in case if there was something like the array was something like this, then 7 would also be greater than 4. So you would have to include this as well. And 2 is like covering 4 and 7 in the same subarray would force you to take 2 as well. If you take 2 as well, then you would have to take 3 as well. And covering this would include 1 in the way. So things would go like this. And you might feel like you are not getting any intuition how to deal with this. So one way which I like whenever I have to deal with something like removing a subarray from an array, I treat like the array to be in three parts. The one to be prefix, which is coming before the subarray, then the subarray, which I am which I am searching right now. I don't like when I am given an array, I don't really know that which subarray I want to remove, but I know that whichever subarray I want to remove, it will have a prefix array on the left and a suffix array on the right. You can name anything like left or right. I just call them as prefix and suffix. These are not those prefix and suffix which are commonly used. I'm not talking about those terms right now. So now, can you observe that if you count the number of elements in prefix, that is 2, and the number of elements in suffix, that is 1, this has been adding up to 3, and 3 is the largest term in prefix and suffix. So this much, like I was already being given a permutation of n, which means that every element was coming exactly once. So if the number of elements in prefix and suffix is equal to like the sum of number of elements in the prefix plus the number of elements in suffix is equal to the maximum element in prefix or suffix, then it means that every element till that maximum element like 1, 2, 3 must be coming exactly once, which is the condition for something, which is the condition for it is necessary and sufficient to call it as a permutation of 3. You heard in the example, like in the problem statement, that permutation of n is nothing but all of the numbers from 1 till n, from 1 to n, occur exactly once. So the converse is also true, that if every number from 1 to n has been coming exactly once, then you can say it as a permutation of n. The converse is also true, and we will use that property. So now, um, if you look at this, You could have done the partition in this manner as well, that 3, 1 and 4 in the prefix, 6 and 5 to be the subarray in the subarray, and 2 as the suffix. This is also valid. It has a lesser score, but it has a score of 2 and this had a score of 3. The score will decide. You can say that if the uh, smallest value in the subarray which you have been choosing is small, it means that it will be the subarray will be having more elements. Can you say it like that? Or maybe we want to call it like the maximum element of prefix and suffix. The maximum element of prefix and suffix should be as small as possible, because if you have this as small as possible, then it means that the subarray would be as huge as possible, which means that the score of wait a minute. I'm really sorry for the interruption. Like रात के 4 ऑलमोस्ट 4 ही बज रहे हैं, तो बाहर से बाबा जी गेट पे खटा रहे थे कि अंदर से आवाजें क्यों आ रही हैं इस टाइम पे। तो um, कुछ नहीं, अब तो हो गया काम। सॉरी। So basically, we realize that the number of elements in prefix and suffix should be minimum. We want them to be minimum. Or you can say that you want the maximum element in the prefix and suffix to be minimum. In that way, like here, the maximum element in prefix and suffix is 4. That is why we are having a lesser score. The score here is 2, and the score here is 3, where the maximum element is smaller. So we got it that our objective is to like have the maximum element in the prefix and suffix to be as small as possible, and as soon as we realize that the number of elements in prefix plus the number of elements in suffix is equal to the maximum element in prefix and suffix, then we can say that if I just remove the subarray from in between, then after concatenation of these two parts, it will form a permutation. So we are really close to the solution now. We have got the most important observation for this problem, and now we just need to understand that how are we going to decide this, like how are we going to decide what should be the prefix and what should be the suffix. So for that, let me take this example once again. This example is really good, I think. 314652. By the way, this is the third time I have been recording this video. I started at around 1:30 a.m. in the midnight, and when the first time I recorded the whole video, I realized that the microphone in the like the microphone permissions in the laptop was disabled, so there was no audio in the recording. And the second time when I recorded this video, I realized that I had forgot to plug in the microphone, so the audio quality was really bad. That's why I've been recording for the third time. So please do like the video and share if possible, and please subscribe to the channel if you think that you want to watch more videos, more such videos. And let's come up to the topic now. So at first, I'm going to assume that this whole is my subarray. Can I assume it? Yes, obviously I can. And now, first of all, like I don't want to have the whole subarray, like the whole array as this subarray. I cannot have it. I must have it at max of length n minus one. I cannot have it of length n, because by the way, just imagine that if I have it of length n, then nothing is remaining, na? That's why in the problem it was being said that you cannot have it of length n, because it doesn't really make any sense for the problem in that case. Now what I will do is compare the first and the last elements. What do you think? Will I be willing to have this in my prefix or this in my suffix? I want the maximum element of my prefix and suffix to be minimum. So if I have to choose between one of them, why should I choose three? I would directly choose two first, right? I would go with two, and everything else is just here. And this is the subarray, right? Like this is not my answer. This is the subarray from which I'm going to choose the answer. Like I'm still trying to find the answer. And here I saw that this is my suffix. The maximum element in my suffix is 2. I can maintain it somewhere like e, max e, and that is 2. And like these to be as low and high pointers. So here low is equal to 0 and high was equal to 5. That is the last element. Now, when I have already taken this, it should point here. This should be pointing here. The high should be pointing here and the low should be still pointing here. Now, when I have to pick one of them, why should I pick 5? I would go greedy. I know that picking 3, like even if I pick 5 here, then still I have to pick 3, right? Because if I pick 5 in this suffix, then for the prefix plus suffix to be a permutation, I need to have all the smaller values than 5 to be mandatorily in the prefix and suffix combined. So I still need to take 3 in that case. So why should I pick 5 first? First of all, I will pick 3. And in the next pass, you will see that this will turn into this. This will turn golden by magic. This is prefix, this is suffix. Let's write prefix and suffix. And I think that now you would be able to see that we are really close to solve the problem. And let me be clear that this was not a really simple problem. This was like the concepts being used in the problem were really simple, but this was twisted. And for a beginner on its own, it was not easy to be solved. And I really tried my best to keep it as simple as possible. I tried to be as slow, like I was not going really fast and I didn't want to go really slow as well. So let's solve ahead. Let's not waste our time here now. And thus high is at 4 and the maximum element is now 3. Okay. Now shall I pick one? Obviously, if this is smaller than the maxi, I don't like even if I had two choices, low and high, to maintain like to keep things simple, I'm going to pick the lower one. But even if let's keep it simple and just pick the lower one. Let's make those things. So we will just pick the lower one. Just picking the lower one will also get me to the right answer. That's why I'm not explaining what I wanted to. It will actually overcomplicate things for you. And now low is implemented to 2. Um, now the real reason why I was maintaining low and high. One of the reasons was that I can maintain this. You could have maintained something like prefix length and suffix length to keep track of these lengths. Or what you can do is that if low is equal to 2, if low is equal to 2, it means that the elements at index 0 and 1 would be included in the prefix. So 0 and 1, that is 2, plus high is equal to 4 and n was equal to 6, right? Which means that the maximum value for high could have been 5 and right now high is equal to 4. It means that there would be one element in the suffix. So taking it there adds up to 3 at every step whenever we had been comparing. So, like before comparing, what we are going to do is just check if the number of elements in prefix and suffix is equal to the maximum element. This is my max element right now. So max element is equal to 3 and the low that is the number of elements in the prefix, and n minus 1 minus I, that is the number of elements in the suffix, is equal to 3, which is equal to max C. That means that I have got the subarray which I wanted. This is gonna be the optimal subarray. We have gone we we did everything really slowly, everything step by step. So I hope that you are able to understand this much, and we will revise this once again while looking at the code. So let's solve these sample examples first and then go to the code. The reason of solving these examples is that you will get uh, it revised once again. So here is the low, here is the high. I'm not writing the stuff which I wrote there last time. Just do it fast. So the low is small. Yeah. So the low is small, which means that I would keep it in my prefix. Now the low is here and this is gone. Now in the low and high, low is smaller, so I will take the low. The reason I'm picking another element is because the max element is 2 and the number of elements in prefix is just 1, so I need to pick another one. After picking another element, uh, this is the maximum element is 2 and the number of elements in this prefix is also 2. Here we don't have anything in this suffix. If there was something in suffix, we would have included it as well. There are two elements in prefix and all of the elements and the maximum element is also 2. It means that every element from 1 to 2 would have been occurring exactly once, which means that this is a permutation of length 2. So if I just remove everything else, if I just remove everything else from the from the array, I will have the maximum score. That's why the answer is gonna be 1 here. It's 1. And for this case, let me show you this as well. Then 1, 2, 3, 4, 5, 6, 7. This is low. This is high. For the low part, when you compare low and high, you will see that low is smaller. So take this in the prefix, and this is the array where we would be looking for the solution. Now this is low, but wait, this is 1. The maximum element is 1, and the number of elements is also 1. 1 is a permutation of itself, right? Sorry if I said it wrong, but what I want to convey is that 1 in itself is a permutation of length 1. So you can just take off everything. Now the answer is going to be equal to n minus length of prefix plus length of suffix. So length of suffix is 0 and length of prefix is 1. So n minus 1 is the answer. Here 6 is the answer and minus 1 that is. Now let's look at the code. So in the code, first of all, we have been taking the length and the array as input, and afterwards we have been defining the two pointers low and high at 0 and n minus 1. And this range variable is nothing but the variable which we had been using at maxc. I just named it different during the contest, so that's the same stuff. It is doing the same stuff. So while low and high, low is less than high, I'm going to say that low plus n minus 1 minus high. Low is the number of elements in prefix and this is the number of elements in the suffix. If this is equal to range, which is the maximum element in prefix and suffix, then I will just print the answer. That is gonna be n minus the maximum element and then return. And if this condition doesn't is not met till now, then what we are going to do is just compare them and take the smaller one into our prefix or suffix, and at the end I just set to cout one Though I think that it would come here, it would at the end get a return here. Anyways, just to be safe, I just wrote it here. You can ignore it. And initially, when I declared the variable range, I initialized it with a value of minimum of num0 and nums n minus 1 because I was going to pick one of these values for sure. That's why because low and high were there, so I was forced to pick one of those values at the starting. That's why I just initialized it with it. In case if you don't want to initialize it in this manner and just want to initialize it with 0, then in that case you have to write this statement down and these statements before. So you would get a wrong answer. And by the way, you can just look at my implementation. After this, like we have thoroughly gone over the implementation, the intuition approach, and like the algorithm also, and then the code. So after this, if you have any doubts remaining, first of all, try to figure out them on your own because in the contest, you would be dependent on yourself only. You won't have someone else to help you during the contest, so you have to like make this as a habit that whenever you are not able to understand the editorial, then you have to try your best at it, try to solve it, watch it again and again. But even if after that you are not able to solve it on your own or understand it, then you can ask about that in comments. And in case if you were able to understand it in the first go, then please tell me in the comments. I would be really happy to like look at the comments. So let's go to the seventh problem. The seventh problem is gonna be like I'm sure that it's gonna be rated at least 2200, and this is kind of a simple problem. It's just like people are not able to figure it out. So as we discussed earlier, that in the starting problems, they were really simple. They were just like syntax based problems, but they had a syntax like they had a story behind them, and the user, like the participants, which we were, we had to understand what we need to do. We were not being directly told that just write this and you will get the answer. Here, when we went to the fourth problem, we realized that we have to do some computation on our own. When we reached the fifth problem, we realized that nothing is going to be given to us directly. The things were started to get a little tricky. We were being given information indirectly. In the sixth problem, we realized that it required good amount of observation to us to solve this, and it actually required some concentration as well. You need to like the concepts being used were really simple, but the problem was really twisted. Now, as you go further and further, you will see that the concepts, the topics are also gonna be more messy and they are gonna be super tricky. So this is another example of that. The concept being used in this problem is really simple, but like guessing the uh, concept which we have to use is something which a lot of people face problems in. Um, though it was comparatively a simple problem, there will be way more messy problems than this at the seventh stage. Now let's discuss this problem. So it says that chef has an array A of size n such that all the values of array A are between the range 1 to k for all of the indices from 1 to n, and B is an array of size m, and the same is true for Bi as well. Now you can perform the following operation: select an integer x in this range, and append it to the end of exactly one of the array among A and B. So you can choose any of these array. You can choose any number in the range from 1 to k and append it into any of the array of your choice. Now we have to find the minimum number of operations required to make mean of A strictly greater than mean of B, or determine it is not possible to do so. So, talking about the case when it would not be possible to do so, this is something which, when I was doing the contest, it didn't come to my mind directly by just looking at it. But when I went to the test cases, I realized that if k is equal to 1, then I cannot do anything. If k is equal to 1, then it means that all the values of ai are gonna be equal to 1, and all the values of bi will also be equal to 1, which means that, and by the way, all the variables which I can insert would also be of value 1. So I cannot change the mean from 1. It would remain 1, and that's why I cannot get any answer. So I have to print -1 in that case. And this has been explained like what is mean. Mean is just the average of all the numbers. So take out the sum and divide by the number of elements in it. Okay, so when you come to this problem, the input is something like the size of first array, the size of second array, and the range in which the inputs would be. And let's take this test case, and there is something which I want to show you. 373524. 835. These are the two subarrays. These are the two arrays. And now, um, in each operation, what you can do is either append something to A or append something to B. Here, we know that we want the mean of A to be greater than mean of B. So, what should come to your mind directly in the first, like the first thing which should come to your mind is that if I'm appending something to A, then that is gonna be the value of K. Here K is 9, so if I append anything in A, then it must be 9. I won't append anything else. And if I'm appending something in B, I want to take down, uh, at the starting, you can say that the mean of A is something here and the mean of B is something like here, something like this. I want A to go above B. So I will append something which is at a higher level. The value of K is higher. So I would append something of high value so that mean of A goes higher. And when I want to append something to B, then it is definitely going to be 1 so that the mean of B goes down. So this thing should be like really obvious to you. After this, we have to find the number of operations after which mean of A is gonna be greater than mean of B. So um, like I don't know that when you have been watching the video, I don't know how much experienced you are, how much familiar you are with the basic concepts like binary search. But for uh, someone like a four-star coder or maybe higher who has practiced enough questions on binary search, this would directly come to his mind that what he would do is just try to think that if he can make mean of A greater than mean of B in 8 operations, then in the ninth operation, it is definitely going to be true for that as well. For the 10th, 11th, 12th, and so on. So if you can do it in 8 steps, then obviously you can do it in 9, 10, 11, 12, 13 steps as well. If you fail to do it in 5 steps, just imagine if you tried all the way, all the combinations for 5 operations, and now you realize that you cannot make mean of A greater than mean of B in 5 operations, then it means that you cannot do it in 4, 3, 2, or 1 steps, right? So we are going to use this information. Um, if you have studied, then that is something called as a monotonic function. Like we can create a monotonic function for us here. Let's not complicate things. If you know already, then that's good. And in case if you don't know about that, don't worry. You don't really need to know about the names to solve the problem. Here the concept is simple that I am going to search like a binary search. In case if you have never solved up any problem like this using binary search, where you try to create a monotonic function on your own, predicate function basically. In that case, you can skip the problem for now because like it would be overwhelming for you to try to understand this problem, and this is obviously the seventh problem. So if you are like a 2 or 3 star coder, then you don't really need to upsolve till the seventh problem if you face problem in it. Because a lot of times people try to solve hard problems, and then when they are not able to understand it, they just lose their motivation of solving hard problems. So it's better to avoid it instead of losing the motivation. And obviously, different people can have different mentalities, different opinions about this thing. So it depends upon you. Now, what is going to be the minimum number of operations? We have been considering that k is not equal to 1. We have been considering only those cases when k is not equal to 1. In case if k is equal to 1, then the answer is minus 1. Then answer is minus 1 if k is equal to 1. But for other cases, we are going to find the answer. So what can be the minimum number of operations? It can be 0. If the mean of A is already greater than mean of B, then the answer is 0. What can be the maximum number of operations which are required? So let us take a case then that A consists of ones and times. There are n ones, like A is of size n and all of them are ones. B is of size k and like B is of size m and all of them are k, which is the maximum value. So even in the worst case, what you can do is append uh, n ones here, n ones here, and m k's here. Now A and B will become kind of equal, and just append k here and like appending 1k in this one more k here will make the mean of this greater than this. So the maximum number of operations you would require is n plus n plus 1 to be safe sided in case like during a contest, in case if you are not able to uh, count the number of operations at max, then like you can just take a really huge value like 1e9. uh, though it doesn't really make much of sense to take 1e9. By the way, in this problem, if you take 1e9, then it will fail. For this problem it will fail. For this like this kind of problem you have to find this. But if you have solved other problems, you would have realized that in a lot of problems you can simply take 1e9 or 1e5, 1e7, something like that, depending upon the constraints. So we will start from 1 and at n plus m plus 1. Initially I am saying that my answer is n plus m plus 1. Why n plus n plus 1? Because I know that if k is not equal to 1, in case if k is equal to 1, let me show you in code how we write it. So if k is equal to 1, you directly print the minus 1, like this minus 1 is equivalent to the thing which is written here is equivalent to this. So we are directly printing it and just returning. So we go to the next iteration, the next test case. So I'm going down only when this is not equal to minus. This is not equal to 1. Now I know that n plus n plus 1 operation is something after which I can get my answer for sure. I won't have any difficulty in this case. Okay, so What we can do now is just imagine if I have seven operations. I want to check for seven operations if it is possible to um, uh, make mean of A greater than mean of B within seven operations. So to confirm it, I can just simply apply a loop from 0 to 7, from I is equal to 0 to I is equal to 7, and this I is the number of times I would be adding, I would be applying operation on A, and the other one is the number of times, like you can say operation on one, operation on A, OPA is equal to I, and OPB is equal to n minus I, not n, but if 7, let's call that 7 is mid, so it should be mid minus I. Mid minus I should be the number of operations I am applying on B. And obviously, I know that I can pre-compute the sum of these terms, which is going to be common every time. And I can find the mean by just saying that if this is something said as sum A, and I've been applying operation OPA times, so OPA into K, and just divide it by n, which was the original length, plus OPA, which is the number of operations I've applied, because in each operation the length of A would increase. So by doing this, which takes me of 1 for each iteration, I can find the mean of A, and similarly I can find the mean of B. And in this loop, for every value of I, from I is equal to 0 se the, from I is equal to 0 to I is equal to 7, for every value of I can find if mean of A is greater than mean of B or not. And as soon as I find that mean of A is greater than mean of B, then I can simply say that yes, for 7 operations, I have a way in which I can um, make mean of A greater than mean of B. And if I don't find any, I can just return false. So, considering the difficulty of this problem, in case if you're not able to understand this, then you can leave it. There is no problem in it. I'm saying that even if you are a 3-star or lower, like 1-star, 2-star, or 3-star coder, then you can leave this problem. But if you are a 4-star coder, then you should definitely absolve this. And I have not explained it really like step by step because considering the difficulty of this problem, I am assuming that if you have been trying to solve it, you are already skilled enough to just find the algorithm by looking at the intuition. Because explaining line by line is not good for the hard problems. And let me show you my code. So I'm pre-computing the sum of A and sum B, and then here is the binary search. Like for binary search, start is 0 and n is equal to m plus n plus 1, and start is less than equal to n, and then finding the mid, then checking for mid, sum, a, and passing these like just passing these arguments, and then if it return true, then the answer is equal to mid and is equal to, like, I think that you would be able to understand this on your own, and you can ignore these debug statements. These are just for debugging, and they work on the offline ID like Sublime Text where I do code. So like having them or not having them doesn't create any difference for the online compiler, and you can remove them. And in the isValid function, I'm just like at first I'm adding everything in A and nothing in B. Like you can just understand by reading this, because I have been saying this multiple times that considering the level of difficulty of this problem, I'm assuming that you're already skilled enough to understand it. So you can read the code and understand. Like spoon feeding is not good at this level. So I hope that this editorial was helpful for you. And if you watched till here, then thank you so much. And please leave a comment so that I can know that you watched it till here. And thank you so much. I will consider like I will think I will make a video on the eighth problem as well. Currently, I have not even solved it myself. This problem was a little complicated. So, if you have any doubts, then feel free to ask in comment section. And if you don't want to ask in comment section and want to ask it personally, then you can text me on LinkedIn. Or if you are connected with me on WhatsApp, then you can comment me on what like you can text me on WhatsApp. So thank you for watching the video and bye bye.